Hey students, good morning. This is Mr. Bob. In this video, I'm going to give you some pointers on how to make sure you collect the best possible data for the lab, where you are looking at how the circular motion or how the acceleration of an object moving in a circle varies with the distance that it's from the center of that circle, the radius. So as you can see here, we have our setup of a turntable and we have the device. This is an accelerometer. I'm going to say more about that in the next segment. So please watch carefully and feel free to refer to this video as often as you need to make sure you collect good data. So let's make sure we understand the big picture. This is what's called an accelerometer. It's a device So let's make sure we understand the big picture. This little rectangular box that I have here is called an accelerometer. And it's a device that just basically measures the acceleration in any direction that we want it to. In this case, we're going to measure the acceleration in the X direction. I don't know if you can see that, but notice it has an X, Y, and Z right there. And we're always going to aim that X arrow towards the center of the circle. Okay, so in other words, when we paste it on a turntable here, we're always going to place it with that arrow towards the center. And what you're going to do is you're going to place it towards the center, and then you're going to have it start spinning. And this is going to be connected to a laptop that you'll see in a second how you do that. Collect some data, stop it. You'll do a second trial, same thing, where you collect some data, stop it, and then you're going to move it out. And the other thing you're going to do is you're going to measure the distance from the center of the circle to that spot very carefully. And over the 7 or 8 trials that you do, 7 or 8 settings, 2 trials at each setting, you're going to get some data that's going to allow you to help analyze the pattern. You can type in on Chrome, you can type in Vernier Graphical Analysis Chrome Web Store. Okay, so Vernier Graphical Analysis Chrome Web Store. If you do that, you will get something that looks like this. And when you click on that link, make sure you get notice you'll get this, and you want to make sure that it is definitely on your Chromebook. If it's not, there will be a different button here that says something like download or apply. This one says launch, and so notice I can launch the app. Now, when you launch the app and you go to new experiment, you're going to get this screen, and on this screen you're going to want to go to sensor data collection. When I click on that, notice if you look closely here, there is something that says discovered wireless devices, GDX-ACC0H103166. Okay, you want to make sure there's going to be several devices live in the room, so you want to make sure that matches this, which is written on the side of your device. So notice 3166 matches 3166, so you're good. But if it doesn't match, or if there's a couple devices, make sure you pick the one that matches. Otherwise, you're going to be collecting data on an accelerometer that you are not using. You will know you are connected if you see up here in connected devices, your device's number listed. So when you measure the radius of your device, this is a really important thing. You want to measure from the center, but to what point on the device do we call the center of the device? Vernier has made it very convenient for us, and again, this little spot right here, which I'm pointing to with the corner of the ruler, is considered to be what's called the center of mass. So in other words, when you're measuring the radius, I would measure this to go from this point here that I'm showing you to that dot in the center. So roughly, as I measured here, that's about 65.0 millimeters or 6.5 centimeters. So now what you will do is you will start your turntable, whichever way you have it, get it spinning, make sure it's spinning up to speed, and then on your device, on your laptop, you will hit collect. And notice what's going to happen. You maybe can't see it, but there is data being collected down there. You can see it. You let it run for a few seconds, and then you can have the turntable stop, and you can stop the data collection. So we have this data. We want to scale it so that we can see it more clearly. So down here, there's a little button. It says zoom to all data. And notice that's a convenient button because then it kind of gives it to you in a format like this. Next, what we want to do is we want to take an average of the acceleration over several seconds. So if we go something like this, okay, for several seconds. And then down here in the corner, on the lower left corner, you have this little button here that says Graph Tools. Click on Graph Tools, and then notice there's another button up here that I'm pointing to called View Statistics. When you click on View Statistics, you get this box of information. There's a lot of information here, but what you want is you want the average. Another word for average is mean. So for this setting of radius, the average acceleration is 1.356 meters per second squared, and you would want to write that down on your table. And then obviously you would do that again, a second trial at the same setting, get another set of data, and then you would go back over here and move the accelerometer out to a different radius and repeat the whole process until you're done taking all data. Another part of your data collection involves determining the period, the time for one revolution of the turntable, independent of what you're doing with the accelerometer. And so there are a lot of different ways to do this, but I'm just going to suggest to you one way to do it is to just put a little flag or something, ruler, piece of tape or whatever, at some certain point on the turntable, and then get a timing device out. A smartphone would work. There's also some pink timers that I have in the room. And then you coordinate with one of your teammates. They get it moving. And then you start the timer at a certain point. And a tip here that is important to realize is let it go several revolutions, maybe 5 or 10 revolutions before stopping it. Why? Because you're going to find out, and we'll talk about this in class some more, that the uncertainty, the percent uncertainty, if you let it go for several revolutions, is much better, is minimized, as opposed to if you just start and stop it for one revolution. So that's a tip I have on how to collect the period data. So those are some helpful hints that will hopefully allow you to get some pretty good data. Finally, to wrap it all up, a quick little story. Over the weekend, woke up in the morning and saw a spider in our room. And my wife was like, don't kill it, just take it out. So I did. So we went out for a latte at Starbucks. The spider told me about its life. They're pretty cool. They're a web developer.